Hello everyone, today I will talk about finding Fibonacci number in log n time. The classic process to find the Fibonacci number is recurrence method. You are given the first two terms of Fibonacci number. They are 0 and 1. And each subsequent term is sum of previous two terms. However, this method is very inefficient. So a dynamic solution is proposed. A dynamic solution is only to use last two Fibonacci number for the computation. You can see here last two terms, a swap and the sum of previous two terms. Swap and sum. Swap and sum. The linear equation can represent the dynamic process, and its metric representative equivalent to this linear equation. So the dynamic process can be represented by the matrix multiplication. Recursively use this multiplication, we found that these two matrices are equal. It is a very important property. Based upon this property, the n plus m plus 1 term of a Fibonacci number can be decomposed to two-power matrix multiplication. After expanse multiplication, the m plus n term is equal to this summation. And n plus m minus 1 term equal to this summation. When we set m equal n, we found the even term of Fibonacci number can be represented by this equation 1, and then the odd term of Fibonacci number can be represented by this equation 2. These two equations provide us a way to find a Fibonacci number in log n arithmetic operation, since we can divide the problem to half recursively. Alright, let's see the code. To avoid solving subproblem multiple times, we use Python decorator. List the recently used cache from the standard library func_tools. To find the Fibonacci number, we split the problem into even and odd portion recursively. That's all for today. See you next episode.